Hello everyone. In previous portion we had discussed about the intrinsic semiconductors, that is the carrier concentration for holes and electrons in Fermi levels as well as in energy bands. Okay, so now we discuss about how can we derive the equation for Fermi level from the intrinsic semiconductor carrier concentration. Here Ne represents the carrier concentration of electrons and NH represents the carrier concentration of holes. For intrinsic semiconductor or a pure semiconductor, both the carriers are equal in density. So we can equate these two. In previous section, we had derived the equation for Ne and NH. So by equating these, 2Me kBT divided by 2 pi h cross square all raised to 3 by 2 exponential EF minus EC by kBT equal to 2mH kBT divided by 2 pi h cross square all raised to 3 by 2 exponential EV minus EF by kBT. See here there is only difference in the electron effective mass and hole effective mass and the conduction band and valence band. So note out the differences. By equating these two, cancel the equal terms on both sides. 2 get cancelled. Then this kBT and 2 pi h cross square get cancelled. The remaining terms in the next section is Me raised to 3 by 2 exponential EF minus EC by kBT equal to MH raised to 3 by 2 exponential EV minus EF kBT. Then rearranging Me by MH all raised to 3 by 2 equal to E raised to EV minus EF kBT into exponential when it comes over here EC minus EF by kBT. Then rearranging exponential EV minus EC, EV plus EC minus 2EF divided by kBT on right hand side. Then taking logarithm, natural logarithm, Me by logarithm of Me by MH all raised to 3 by 2 equal to EV plus EC minus 2EF divided by kBT, or EV plus EC minus 2EF is equal to 3 by 2 kBT log Me by MH. Okay. Then from that 2EF is equal to when comes over here on right hand side, left become EV plus EC, then minus 3 by 2 comes to the left, so it become minus 3 by 2 kBT log Me by MH. Okay, then this term EF is equal to Fermi energy EF is equal to EV by EC by 2 minus 3 by 4 kBT log Me by MH, or EF is equal to EC plus EV epsilon C plus epsilon V divided by 2 plus 3 by 4 when this logarithmic term taking reciprocal MH by Me by changing the sign. So this will be the Fermi level in terms of Hall and electron effective mass. That is, Fermi level depends on the energy of the conduction band and valence band, that at topmost filled level of valence band and bottommost filled level of conduction band, that is conduction band edge and valence band edge energy. Then it depends on the effective mass of holes and electrons at the same time depending on the temperature also. So EF depends on effective mass of electrons and holes. Then at zero temperature this term vanishes. So the remaining term will be only EC plus EV by 2, that is half filled orbital level. Fermi level lies in the middle of the conduction band and valence band at 0 Kelvin. This is true for all other temperature provided MH and Me equal to when the effective mass are equal, this is true for all other temperature. അതായത് ഈ MH ഈക്വൽ ആയാലും വേറെ ഏത് ടെമ്പറേച്ചറിലും നമുക്ക് ഈ ടേമിന് ഹാഫ് ഫിൽഡ് അതായത് മിഡ് വേയിലാണ് ഫെർമി ലെവൽ ഓക്യുപ്പൈ ചെയ്യുന്നതെന്നുള്ള കാര്യം പറയാൻ പറ്റും. ഇൻ ജനറൽ mobility, that is effective mass of the holes, is greater than effective mass of the electron. So EF is slightly raised as T tends to exceeds 0 Kelvin. അതായത് നമ്മുടെ ജനറൽ കേസിൽ ഇഫക്റ്റീവ് മാസ് രണ്ട് ഈക്വൽ അല്ല. ഇഫക്റ്റീവ് മാസ് ഓഫ് ഹോൾസ് ഈസ് ഗ്രേറ്റർ ദാൻ ഇലക്ട്രോൺ. സോ EF നോർമലി ടെമ്പറേച്ചർ കൂടുതലുള്ള, അതായത് 0 കെൽവിനിൽ അത് മിഡ്വേയിലാണ്. 0 കെൽവിനിലും കൂടുതലുള്ള കേസിൽ നമ്മൾ ഇപ്പോൾ പറഞ്ഞല്ലോ, മിഡിൽ തന്നെയാണ് ഓക്യുപ്പൈ ചെയ്യുക ME MHും ഈക്വൽ ആണെങ്കിൽ. പക്ഷേ ME MHും ഈക്വൽ അല്ല എപ്പോഴും. MH ഹോൾസിൻ്റെ മാസ് എന്ന് പറയുന്നത് ഇലക്ട്രോൺ മാസിനേക്കാളും സ്ലൈറ്റ്ലി ഗ്രേറ്റർ ആയതുകൊണ്ട് ഈ പറഞ്ഞ എനി ടെമ്പറേച്ചറിലുള്ള വാല്യൂ എപ്പോഴും അതായത് EFൻ്റെ ലെവൽ മിഡിലാവണം എന്നില്ല. For silicon at 300 degree, increase in EF is about 0.01 electron volt only. അപ്പോൾ അതൊരു വാല്യൂ അവിടെ എക്സ്പെരിമെൻ്റൽ വാല്യൂ പറഞ്ഞുകൊണ്ട് the position of Fermi level is given. Now we have these equations of Ne and NH. So from that we need to find this total intrinsic carrier concentration Ni for intrinsic semiconductor. Ne equal to NH, so it can be designated as Ni. Then the relation to find this total intrinsic concentration is equal to Ne into NH is equal to Ni square. From that, Ni is equal to root of Ne NH. So firstly find this product of Ne into NH. Ne relation is here, NH is here. Then taking product 4 times KBT. This KBT 3 by 2 into 3 by 2 term become cube. Then ME/MH all raised to 3 by 2 term is there. Then exponential EV minus EF. Here EF minus EC and EV minus EF. So together it is EV minus EC. EV minus EC. These two get cancelled. EF. So exponential term for total intrinsic concentration for total carrier concentration for intrinsic semiconductor. Ni is equal to root of NeNH. It become, this is the total product of NeNH. Here it is 2 into root of this term. So 2 into KBT by 2 pi h cross square all raised to 3 by 2 MENH 3 by 2 in the root എടുക്കുമ്പോൾ 3 by 4 e raised to minus EG by 2 KBT. 2 KBT. Here there are two terms. So 2 KBT. EV minus EC is equal to EG, therefore it is replaced as EG over here. Okay, EV minus EC is EG, then e raised to minus EV minus EC is minus EG actually. Why it is minus EG? EC is the higher value, so EV minus EC become minus of EG, thereby e raised to minus EG by 2 KBT. At exponential as temperature increases exponentially, here the term for temperature increases exponentially, number of carrier concentration also increases. Now next we have this terms drift velocity, mobility and conductivity of the intrinsic semiconductor. So at 0 Kelvin both the carrier concentrations are same. If we are not giving any external applied force, no change in the number of electrons as well as no current is produced. See, if we give the external electric field is applied, that is if external electric field is applied, electrons and holes will begin to move with a drift velocity. So what could be the drift velocity? The extra velocity acquired by the charge carrier in the presence of external electric field is called the drift velocity Vd. Therefore, this drift velocity proportional to applied electric field, and that proportionality constant is the mobility of the charge carrier. So, we have the equation for Vd is equal to mu into applied electric field. Then current density due to the electron, it is Ne, that is electron concentration, into charge of electron into drift velocity. Substituting for drift velocity here, this entire term represents sigma, the electrical conductivity due to electrons. So the conductivity current density term JH can be replaced as sigma into Ne into E, this mu. So this represents the JE. Then in terms of holes, we have the same values for NH and charge of holes, then the drift velocity of the holes by substituting the drift mobility of the holes. So we have another term for current density due to holes also. So total from here this term mu NH E mu H becomes sigma H. So substituting that will be the electrical conductivity term for holes. So total conductivity become total conductivity. Here the electrical conductivity of the holes and electrical conductivity of the electrons. So total conductivity sigma E into sigma H become E into Ne mu E plus Nh mu H. We know this Nh and Ne are same. Since these two are same, we can take an outside as Ne. So total electrical conductivity of intrinsic semiconductor sigma is equal to Ni into E into mu E plus mu H. So this will be the electrical conductivity of intrinsic semiconductor. And by substituting this term, this Ni, total concentration, carrier concentration for intrinsic semiconductor, we can have the electrical conductivity variation with the temperature. That is, this term for this Ni consists of the term for temperature. Therefore, by substituting this Ni term, we have this 2, what is the value of sigma? Ni into E into mu E plus mu H. So here comes this mu E plus mu H. Here comes this term 2 times this entire term represents Ni. Then we have this additional term for this carrier. So charge of the carrier. So the effective term for electrical conductivity is here. Taking logarithm on left hand side, we have the expression log 2e mu e plus mu h into kb divided by 2 pi h cross square raised to 3 by 2. T is taken outside. Then me mh 3 by 4 e raised to minus eg by 2 kbt. Kbt term. Here this term is missing. We need to add this term mu e plus mu h. Here it is. Here I had put in the first section. So we have this log of sigma is equal to constant plus this term 3 by 2 log of the entire term that is kb by 2 pi h cross square. Then we have the last term for the logarithmic value minus eg by 2 kbt. So from this logarithmic term of electrical conductivity is entirely depend on the energy, gap and temperature. The rest of the terms are constant. So when we plot this 1 by sigma over 1 by t, the graph will be like this. And we plot the 1 by log sigma versus 1 by t. That is graph will be like this. For the n-type germanium silicon conductor, this value is given. Here it is given. So these are the Fermi level, the value of Fermi level in terms of carrier concentration and total intrinsic carrier concentration for intrinsic semiconductor, drift velocity, electrical conductivity and variation of electrical conductivity with the temperature.